Okay. Question 24, page 24. Abia is measuring the distance between a gondola, travels between the base and the cabin at the top of the mountain. The angle of elevation from the base of the cabin is 46 degrees. It shouldn't surprise us. Can I say something? Diagram trumps whatever is written for trig, especially. Sometimes they're like, what? Students were like, what? Like, just look at the diagram, right? So this is there. This is your angle of elevation. The angle of elevation from Abia to the cabin is 70, right? So looking up to the cabin, the angle of elevation is 70 here. Calculate the measures of angle A and angle C. So they want, right, let's use different colors. Angle A is this one right here. What do you think of when you see that? Supplementary, hopefully, right? A and 70 add up to 180. So angle A is 110 degrees. And angle, sorry, C is the next one they want. 24? Yeah. Yeah. So we'll go 180 minus 110 minus 46. It's 24 degrees. Okay, so these are my two answers here. You're done. Notice that it said calculate because I guess for C it was a bit more than just writing down the answer. So I'm gonna highlight angle C here. So they're setting up the stage here. B, determine the distance between the base and the cabin if Abia is 1,000 meters from the base. Morning. So they want the distance between the base and the cabin. So this is the base, this is the cabin, so they want this side right here. That's what they want to calculate. And I don't think it hurts to redraw, resketch, right? So I'm gonna try my best here, like this. We know this is 1,000. We know that this is 110. This is 24. This is 46. This is the side we're actually after here. Which law am I going to use here? Sine, because I have a pair, correct? Yeah, so this is my pair. So this is the angle. You travel out, you get the side. So sine law. Okay, question 24. So we're going to go sine of 24 over 1,000 meters. And I'm going to have to use, I have two angles to choose from, but I'm going to use 110 to allow me to solve for x. Okay. So that's my setup. And let's solve. So this is cross multiply there, divide. So 1,000 and sine of 110, multiply, sine 24, you divide. Okay. 2,310.32, perfect. You could not have used cosine law in this case because you need two sides and the angle in between, or you need all three sides. Let's keep going. Identify which of the following diagrams best illustrates an isosceles trapezoid. This one cannot be, right, because the base angles would have to be exactly the same. So not. This one is a trapezoid, but it's not an isosceles. This is a parallelogram. So B is it, right? Angle option B is it, because you've got the two sides on the here being congruent and two parallel sides. Keep going. Weird question, I think, but it's only 1 mark, so let that guide you. An engineer is designing a building in the form of a regular polygon that has a central angle of 24. You should recognize, oh yeah, that's a central angle right there. she's using the formula S is over 64,800 divided by C minus 360, where S is the sum of the interior angles of a polygon and C is the central angle of the regular polygon. State the sum of the interior angles of this polygon. State means it doesn't take a whole lot of effort. Okay, so what we're going to do is we're going to take this C. I don't know, this question came kind of out of the blue. We're just going to plug that C in, and then we technically find our sum of interior angles. So 64,800 divided by 24, and then we subtract 360 from it. Divided by 24, it's 2,700 minus 360. It's 2,340. But, okay, everything is connected in geometry and math. Can I just show you something else? Do you remember going backwards, like the backwards question? So I'm just going to say this. If you know C is equal to 360 over N, correct? That's one thing you could have counted. Or, watch this. If you count the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sides. In this case, I could count, but you could have also figured out the number of sides by using this one and working backwards, because you know central is 24. But let's say it's like, hey, I'm just going to count. What's the formula for sum of interior angles? It's n minus 2 times 180, correct? So we would go, well, 50 minus 2 times 180, that's 13 times 180. It better be 2340, or else I'll call the province right now. Okay. 13 times 180. There we go. So yeah, it's a little weird why they did that. But it was just plug in and go regardless, almost, right? So the reason I started with this formula is just because, hey, they give us a central angle, so we could use this to find the number of sides. But why would I do that if I actually have a diagram? Right? I might as well just count. If the diagram wasn't there, then you'd first have to use this to figure out your number of sides, right? So I'm just getting you, I'm painting the big picture here. Keep going. We spent way too much time on that one, given that it's 1 mark, but it's still, it's a precision measurement. I'll stop and start a new one.